So good evening, everyone. Good evening to all and wherever you are from around the world. Welcome to the second webinar of the three-part series of Lean Six Sigma. As you all know, Navrachana University is a leading university based in India, very innovative, interdisciplinary university. And as our part of our collaboration and our conscious strategy to move up the value chain and provide latest cutting edge management practices to Indian corporates, we are very pleased to have tied up with GELRAD in the United States. And we have today all the four founders of GELRAD, Elaine, Praveer, Dave, and Ram, who are watching from the US and from the UK. So we have today Dave, who will be speaking on lean management, which is part 2 of the three-part series. This program is also being streamed live on YouTube and will also be available later as a recording. So thank you so much. Welcome once again on behalf of Navrachana University. And Dave, it's all your floor.
Great, thanks very much. I shall share my screen and we can see the deck. All right, let's do that. And we'll go full screen. Fantastic. Right, so welcome to part 2. Today is Introduction to Lean Management. As we just said a moment ago, I did this on the first webinar, so I'll just do a brief introduction this time as well. My name is Dave Hauff. I am originally from the United States, but I've been living in the UK for almost 23 years now. My background is originally nuclear engineering. That's what I studied in school. I did my master's at Stanford as well, go Trees. And I worked for GE for 10 years, General Electric. And that's really where I learned about problem solving. And that started with workout, which is a rapid approach to problem solving, an awful lot like a Kaizen event that we'll talk about today. And then in the mid to late 1990s, Lean Six Sigma. So that's just a very brief summary of me. Here we are on webinar 2. We did the overview of Six Sigma last week. And then next week, we're going to drill a little deeper into tools and some of the concepts. So it's going to be more the ideas and the thinking level again today, and then we'll look in more detail at the tools next week. And I just want to check, the green light from my camera is now not showing. Can you guys still see me?
We see your still picture and we see all your slides perfectly well.
Okay.
Oh, now we see your video.
It's got a thing saying start my video. I don't know why it switched itself off, but it happened. Okay, good. You guys can see me now. That's better. Because sometimes they do hand gestures. It happens. Good. So, right. So I showed this slide last week again as well. Just want to talk briefly again as a reminder of sort of where we are. So Lean Six Sigma, it traces its roots to many decades ago before all of us were born. Really, the principles started with Toyota and some of them even sooner than that. But Toyota really formed it into the Toyota production system. And that's what we these days know as Lean. Of course, in Toyota, they still call it TPS. But it kind of got the name of Lean in the late 1980s and early 1990s. And it's really based on the principles around eliminating waste that that Toyota spearheaded over many, many years. Six Sigma grew out of that along with total quality management. So they all kind of have the same heritage. It is not uncommon to see the same principles appear in both methodologies. Not that they're distinct things, they all kind of come from the same family, and maybe they have a slightly different focus, or at least the heritage of that is a little bit different, which I'll talk about it again, or just do a refresh of that in a few minutes. So what is Lean? So Lean is also a systematic and disciplined approach, and really it's about increasing value and eliminating waste. That really is the focus of where Toyota started with and what they were looking at. A lot of the tools are really organized around that. But it's not just about the tools and the approach. It really is a philosophy that engages the workforce in relentless CI, continuous improvement. It's really about getting people involved. And I mentioned at the start that I initially started my problem-solving experiences at GE with something called Workout. Workout is very much like a Kaizen event, but one of the great things about Workout is it really engages the people who do the work on a day-to-day basis. And so that's really where one of the ways that lean shines is it's absolutely focused on getting the people who know the best about what's going on. They do the work on a day-to-day basis. They know why things aren't working or what needs to be changed. And it really encourages that ownership and the need to say, when you see something wrong, let's talk about it and let's do something about it and improve it. The principles of lean were laid out in the late 80s, early 1990s in a couple of great books by Womack and Jones. And here they are here, and I'll talk through them briefly, and then that's kind of what we'll spend the rest of our time doing, is going through a little more detail into each of these five principles. So first of all, value. So from the customer's perspective, what is the purpose of this process? What are we actually supposed to be achieving here? And which are the steps that are contributing to that? And in general, it's very few of them. So if you look at most processes, there's really only one or two things that are actually doing what the process is for. Or if you ask the customer, they would tell you, yeah, that's what I'm paying you for, is to do that. And then we crowd loads of other things around that. And that's really what the value stream is about. Let's go have a look at all the activities that are creating the value. And it may not be just in a single process. There may be a whole stream of activities that are coming together to produce whatever the finished product is. So we might have, if I'm manufacturing a car manufacturer, and if I'm manufacturing a vehicle, there's a whole set of streams that are producing all the different parts, and all of these are coming together at the end to generate the vehicle that gets sold to the customer. So let's have a look at all the activities that are doing this and contributing to this, and look for the value in each one of those, and find ways to maximize the value and reduce the non-value added steps. And again, we'll talk more about that in a few minutes. And then we've got pull. So in the lower left, pull is about making things for the customer when the customer needs it. So if you can imagine, instead of pushing things out to the customer, the customer is pulling things through the system. So we only produce something when a customer asks for it. So an easy example goes back a few years. I think McDonald's is pretty much everywhere around the world. Probably most of us have some experience there. And there used to be a time where they would make to a schedule. And the schedule says you make this many hamburgers per minute, this many chicken sandwiches, this many nuggets, and so on. And they would slide down the tray there, and then we would hope that people would buy them. And often that worked, but sometimes it meant taking some of the stuff that had sat under the heat lamps too long and throwing it away. It's much different now. There's a lot less of the waste, because in general, they don't do the assembly until the moment that you ask for it. They've done that very deliberately, rather than a push system that just gives you what the production schedule says. We're pulling through what actually the customer has requested and nothing else. I'm not going to make a bunch of burgers that people didn't order. All right. And then we have flow. So reducing the time between the steps, so that I'm doing just a value added step followed by a value added step followed by another one. There's no delays in there. There's no non-value added steps. I want to just do nothing but do those value creating steps. And there's a lot of different principles around helping to do that. So pull, get what the customer wants, and flow, just eliminate all the waste between the steps of the process. And then finally in the center, perfection. And this is where there's a nice overlap with Six Sigma, is they both are about eliminating defects and making sure we do things right the first time, because it's always cheaper to do it that way. Whenever you make mistakes, you've got to do work to fix it. You've got to do the extra work to undo perhaps what you did before and then redo it again. So let's put some systematic processes in place to make sure we're doing things always the best way right the first time. And often how this is achieved is through Kaizen or continuous improvement. We'll talk about that in a Kaizen event in just a moment. So these are the principles of lean set out in, and again, a couple of books, Machine That Changed the World, Lean Thinking, Womack and Jones. They're great books. A lot of benefits to working in a lean way. Certainly eliminating waste and improving quality. That is the focus there. If I take the non-value things out, do things right the first time, it's gonna be very good for us and very good for our customers there. Freeing up space and time, reducing the human effort and the cost that goes along with that, and drastically reducing inventory. And the numbers can be improvements of 50, 60, 70, 80, even 90% reduction in these areas. Sometimes the benefits of the product are measured in square meters. So how much space in the manufacturing facility did we free up as a result of the work that we've just done here? And then what can we do to use that to grow? And as we said earlier, it really is about empowering the teams, giving people the responsibility to own their processes, own what they're working on, and own that continuous cycle of looking where things could be better and taking action on that. Okay, so a lot of big benefits there. It's important also to say that lean is not mean. Lean is not intended to be about stripping out cost and then stripping out people and firing everybody. If that's how you approach your continuous improvement activities, you'll get one round of that and that's it, right? So typically what happens is if I free up time or I free up space, we find something else to do with that person or that location that then allows us to grow. Because often that's often the challenge is we are constrained by our processes, and that prevents us from being able to grow as a company. So let's free up time. In fact, one of the companies I'm working with now, we're very deliberately from the start, we have deliberately not said this is about saving money. For them, it is all about how do we grow? How do we streamline our processes and make it so that we can grow? We've grown fast over years. How can we grow even faster and achieve the targets that we're looking for and that the market is looking for from us? Okay, so reducing time and reducing costs, we want to take that and use that to reinvest in the business and improve profitability and improve growth. I mentioned a moment ago, doing a Kaizen event. This is typically how lean is approached at the ground level when the groups are actually working on it. This might be an event that you would do over a course of a number of weeks. There, of course, is some planning that is necessary before you do the event, and a number of things you can do, including focusing on the problem that you're trying to solve. And we'll talk a bit more about problem statements in the session next week. Getting idea of the current state, understanding the current process, and we'll talk about value stream map in just a few minutes. And then the actual event. And this is typically where the whole team would come together. Of course, we plan this into our work to say, we're now going to look at, let's say we're trying to improve this area that we're doing some maintenance work in, and how do we make the work go faster through there? So let's look at everything we do from the map. Is the map correct? What else is going on here, and why is it that things are taking so long? And what can we then do to make things go smoother and faster? And some of the tools like Tim Wood, looking at the various kinds of waste. Again, we'll talk about that in a few minutes. Help us to identify those areas that we can improve. And then you finish the event either having already made the changes and it's done. So we get the tools out, we unbolt the machines and we move them around. Or if we haven't been able to do that, we finish with a very deliberate action plan of here's what we'll do in the next few weeks to finish implementing the solutions that we've identified. And then we're going to communicate the success and share that very widely. That is often how it's done, but it's not just in the events. It often happens through how you think and how you work and the questions that you ask when you're a leader and making decisions. Being able to recognize and identify waste when it is happening and come up with really interesting ways to just get rid of it, just eliminate that stuff and just not do it at all, which is really the best solution there. We showed this slide last week as well. There is really, with every project, there are always these three elements there. It's very rare that you'd have one that's all about waste, all about variation, all about complexity. And lean grew out of a world where the focus was on waste. And as we talked about last week, Six Sigma came from a world of variation, but there's never a pure lean design or a variation reduction kind of project. There's always going to be some elements there. And that's why the Lean Six Sigma as a broader toolkit is a great sort of approach to take. I do sometimes meet people and they sort of talk like, lean is this thing way over here that is about waste. And then Six Sigma is this thing way over here that's about variation. But in reality, they are really all from the same overall family of stuff. And so we pick and choose the tools and the concepts that are appropriate for the situation that we're in. Okay, so let's talk about each of the 5 elements. We'll start with a conversation of value. So a step in the process either adds value or it does not. Okay, so it's either value added or non-value added, but we have a special kind of non-value added called value enabling that I'll talk about in just a moment. But first of all, value added. So this process is meant to achieve something, right? It's meant to do an activity. We're producing something, we're delivering a service to the customer. That, from the customer's perspective, that's what you're doing for me. Or if I'm paying for that service, we ask the customer and they would say, yeah, that's what I'm paying you to do, right? It certainly must be done the first time, right the first time. And also another way of looking at it is to say this activity or process step is somehow transforming an input into an output. So I'll grab a pen here. I got one of these handy. So here I've got, I don't know if you can see this on the camera, but I've got a blue Sharpie that's here because it's got a blue lid. And there was a manufacturing process that took some pellet of plastic and turned it into a pen-shaped pellet of plastic, right? And that pen-shaped pellet of plastic is now much more valuable than just the pellet as it was before. So the pen-shaped tube, I can put an ink cartridge in that, and humans can take that and they can communicate with each other, right? So it's actually more valuable now in the tube form than it was as just a plastic pellet there. And that's what we mean by transforming an input into an output. So it could be a physical transformation like the pen. It could also be an electronic transformation or an information transformation, like taking raw data. You know, I've got millions of rows of data. Not a lot I can do with that until I make a graph out of it, which is what gives me the ability to see the insight, to see what's going on, and is maybe there's a change in the process that is important. Okay, so that's what we mean by value added. This is what the process is actually meant to achieve there. Everything else is non-value added. And I'll give you an example here, and then I'll talk briefly about value enabling. So it's been a few months since I've been on an airplane. I used to travel quite a lot, but obviously things have changed in the world. The experience of taking a flight, there's a lot of work to do this activity. So if you think about what happens in a typical flight departure, this is what usually happens for me. I leave home, I get an Uber or something like that, take a taxi to the airport, because I've usually gone long enough that it's not worth it to park there, the cost of that. And of course, you get to the airport, you've got a queue to either check in or at least maybe it's a bag drop that you're doing if you've already checked in online. But usually somebody wants to have a look at your ticket and your passport. At some point, they take your bag and put a sticker on that as well. And then you have to get in the queue for to go through security, right? But they don't just let you into security. They got to check your ticket first to make sure that you're flying today and that you're allowed to go into security. So they check your ticket there. But you got to queue up for that. And then of course you queue up again to actually do the security scan, where then you finally get there and you take everything out of your bag and take out, some places you take off your shoes, take off your belt, all that kind of stuff. And they run it all through the machine. And then you put all that kind of stuff back on there, right? And then I usually have some time to shop at duty free and maybe grab a coffee, something like that. And then have a look at the board for the departure gate. And often it's not posted yet, which gate we're gonna go out of. So we gotta wait for that to be posted, drink the coffee maybe. And then finally the gate's posted, and of course it's not in the main terminal, it's out at the satellite terminal. That means I gotta take an escalator down to the train, wait for the train to show up. I thought I was taking a plane flight, but really it's a train journey apparently. Train takes me out to the satellite terminal. Of course I go back another escalator to get back up to the terminal there. Then I gotta go find my gate, and then sit down, have a rest, wait for the boarding to begin. And then once they finally say it's time to board, I queue to board, I wait in line for that. Once again, they check the ticket and the passport to make sure it's okay to get on the flight and that. And then they let me get through the thing. And then there's usually queuing on the jetway as people are sort of getting in the plane. And finally, you get to the door of the plane, they check your ticket again. And then often you wait in the aisles as well while other people are putting their bags and things up, because your seat's behind where they're sitting. So finally I find my seat, I store my bag, I get settled in that, get my book out or whatever I'm gonna do. Wait while the boarding finishes. Eventually they start closing all the bins of the luggage. They close the plane door and that. And then we wait though for the final notification that we're allowed to leave. So finally the plane pulls back from the gate. Often we queue again on the runway. We wait in a big queue of airplanes, like there's some big giant velvet ropes that are there or something like that. And then finally it's our turn. We get to the end of the runway. The engines rev up, the plane accelerates, and then finally we go forward and the wheels lift off from the runway. And only in that moment am I finally getting what I paid for. Every single thing that happened up to the moment that the wheels left the runway was a non-value added activity. Not a single one of them got me from point A to point B, because that's what I'm paying for. Pay me, pick me up in London, put me down in India somewhere, right? Everything here, none of that does that. In fact, quite the opposite. You've got to make sure you get to the airport early enough to have time to do all of those activities. This is not a 5-minute job to do this. This might take 45 minutes at a minimum to do these activities, and often it is longer than that to do that. And if it's a flight to India, right, that's a long flight. And so the relative balance of time I spend in the airport versus time I'm flying through the air it's not that bad actually. But if I'm flying to Amsterdam, it's only a 40-minute flight to Amsterdam, and I've spent double that or more in sitting in the airport. Okay, so it's very easy to think about steps as being value added just because we have to do them, but that is not what value added means. Okay, so the value added step is when I am flying. That's what I'm paying you for. I'm not paying you to check me to make sure I don't have guns and bombs and things in my luggage. I mean, I don't know about you, but I'm not a terrorist. It's a complete waste of time. More than 99% of our security scans are a complete waste of time. They do nothing. They do nothing other than verify that the people who are not terrorists are still not terrorists at the end of that. But I might call that security check a special kind of non-value added one called value enabling. And this is a step that itself does not add value. So it's not actually flying me somewhere, but by doing this one, it makes the value added steps go better. And that could mean faster, smoother, cheaper, easier, or in the case of the security check, safer, right? So we make sure that we only have the right people on the plane who are not going to try and harm us and do damage there. Okay, so that's what we mean by value enabling. Another example that might be if you want to get a credit card or open a new account at a bank or do something like that, often you fill in a paper form and then you sign it at the bottom and then you give them the paper form. And of course they check to make sure you filled it all in. And then of course the first thing they do after that is they just retype all that same information into a computer system, right? They're just duplicating the same stuff that I just wrote down. My name is Dave Hauff. His name is Dave Hauff. This is my address. This is his address. Like that, all they're doing is duplicating that information. If that was adding value, they should go find the nearest copy machine, put my form on it, and press 1,000 and watch the share price go up. Right? It does nothing to actually produce the value of opening the account and getting me my card and so on. But once I do that activity, now that information is electronic and I can send it 50 different ways at the same time if I want. And somebody can go open the account. Someone can do the credit check. Someone can produce the card and so on. All that can happen at the same time versus what used to happen, which is they would have a big paper pack of all your stuff, and that would get passed around from person to person. It could take days or even weeks for all that to complete. Right, so that's another example of value enabling. Once I do this step, it's going to make the value added ones go better. It's not value enabling just because we think we need to do it today. So if I look at this process map here, at the moment, I have to do every last one of these things. That is what the process says I am supposed to do. All these things. It does not mean that all of those things add value. In fact, none of them do. It's only the flight. Okay, and of course I haven't included everything that happens once you arrive and all the delays and wasted effort that happens there as well. Okay, so this is probably, in my experience in working with lean principles and concepts, this is one of the hardest things to get your head around is what really is the value in the process. And it gets even more complicated when you're working with a team and facilitating or discussing which steps in the process add value and which don't, because there are humans who do every last one of these blue boxes that are on there. And it's a hard thing to say the activity that you're doing does not add value, right? And it's not about the person. You'll notice I didn't say you are not a value-added person. That's not what I said. It's that this activity is not creating value for the customer. And it's actually quite difficult for people to hear that, even if especially if they've been doing it for many, many years, right? So that this is, again, this is about getting your mindset around what we mean when we say value. And it is the hardest thing to do when you're doing this, is to really identify what the value is. It's going to be only 1 or 2 steps in the process. Okay, so to help with that, there's a tool called the 7 Forms of Waste. The acronym to remember that is Tim Wood. I once met a guy named Tim Wood with one of the companies I worked with. He was a very good sport about the whole thing. He let us take a big picture of him holding a sign saying, "I am Tim Wood," and we made a big cardboard cutout of it. And we used it with our engagement activities around Lean Six Sigma. It's an acronym to help you remember what they are. And so I won't cover all of them, but I'll just talk through a couple of them briefly. So transportation. Anytime I have to pick up something and carry it somewhere else to do the next process step is waste. There's nothing useful that's been happening as I simply move it around there. Otherwise, I could just carry it around all day and watch the share price go up. Okay? Motion's very similar. That's about how the workspace is designed and what's going on with the humans. So wasted motion of the humans as they move in the workspace. So that can be a physical space as well. You know, like think about in the offices that you maybe have worked in. Very rarely is the printer on your desk. It's probably off in a corner somewhere, and it may not even be all that close. And no one wants to sit by them anyway because they're kind of loud and smelly and this sort of thing, right? So when you print something, it's often a journey to go get it. And then, of course, you get there and it didn't print right. You know, it printed portrait and you wanted landscape. So you got to go back to your computer, change the settings and go back and then get it and bring it here. That's an example of motion waste. Inventory is where Lean gets its name. This is where we've spent money on raw materials, work in process, finished goods, things that there's capital invested there, and I've yet to have any kind of return from the customer there. So I'll talk more about that later. There's certainly a lot of waiting that happens in processes. There's defects anytime I make a mistake. And then with over-processing and overproduction, over-processing, an example of that is things like the security inspection. Where I'm checking things that don't need to be checked. Really, any checking should be unnecessary. We've got to find a way to get rid of it. Okay, so what do we do when we identify waste? Ideally, what we want to do is find a way to get rid of it entirely. That is the best thing to do. When you see a non-value added step, just get rid of it. Just take it out. Find a way to reorganize things to do that. If you can't get rid of it, or maybe it's like the security check, we are still kind of stuck with it. We don't want to get rid of it. Can I at least simplify it and make it easier to perform? So it's going to consume less time, less resources, less likely to have mistakes and go wrong. Can I synchronize it with other activities so that it's not going to be a bottleneck? You know, put it in parallel. Like the example, once I make it electronically, we can all be working on the account opening process at the same time. Maybe it's sensible to combine some steps and merge it with other steps to increase flow and reduce some of the handoffs there. We'll talk a bit more about flow later. And then lastly, once I've done these other ones, then we can think about automation. It's very common to, when you see something you don't like, especially with some of the companies I work with that are technology companies, the very first instinct is, I should automate that. When actually, it might be better to just not do it altogether. So I was coaching a project once that was about speeding up the month-end close. And there was a whole process around with spreadsheets and macros that would work. And it would take all this raw material and summarize it up. And then they would do some things to it to produce reports. And then they needed some other detailed reports and they would blast out some detail again and macros to do that as well. And there's, of course, time and effort and chance for mistakes here. But in the end, kind of the detailed stuff was pretty much the same as the stuff I started with. So we're actually doing unnecessary things here that we just stopped. Let's just not do that anymore. We've already got the data. We don't need to do this extra work there. And then it's less likely to have mistakes and go wrong. Okay, so again, this is the Tim Wood is here to help us identify, oops, wrong way, to help us identify, there we go, a bit of a delay, a bit of a lag. Tim Wood's meant to help us identify the kinds of waste that's out there. I would encourage you to stop and think about the work you do, whether it's in your career, in your education, even in your house. I bet you are surrounded by waste. There are non-valued things that you are experiencing all the time. And we're so used to them, we don't even notice it anymore. Yeah, we just go through the security check at the airport. We don't even think twice about how ridiculous that is because we know we don't have guns or bombs when we do that. Okay, so I said earlier, value stream is now looking at the process and all the activities that are happening. The map you see here is a high-level value stream map that goes with the laundry example. For those of you who were on last week, I talked about being involved in some industrial laundry a few years ago. This is a value stream map looking at kind of the site level for this particular laundry facility I was working in. And the idea of the value stream map is that we're showing not just the steps that are happening, but a lot more information about what's going on with those steps, and then highlighting where's value being created and where is there waste. So the things you can see, there's some triangles here that have the letter I in them. That, for example, represents inventory. Stuff that is sitting around in the process, nothing is happening to that while it's sitting there in inventory. Okay. And then you have several activities around sorting the laundry and washing it and drying it and so on. I mean, even the sorting activity itself, ideally, I shouldn't have to sort it. Ideally, I'd be able to put all the stuff in together, and it goes in big 75 kilo batches into a big washing machine that it's actually the size of a bus, roughly, is how big this thing is. And it has like a big Archimedes screw with multiple chambers and so on. And it might take a half an hour to sort of get through that process. Ideally, I wouldn't even sort it. I would just throw it all in together, wash it all together, and the process or the fabrics would be able to handle that. Okay, so the value stream map, and then also you got the ladder diagram at the very bottom. That kind of shows when am I working and when am I waiting. And we said waiting a few minutes ago, one of my forms of waste. Anytime I'm sitting in inventory and nothing's happening, that's just waste in the system. Ideally, I would find ways to just get rid of that and move it all the way through. Okay, so you can do this for a single process. You can do this at the site level as we saw here. You can do this, and we can see how multiple value stream maps kind of join together to produce the entire process. I mean, there are maps we could make here around even just how the water and the soap and the chemicals and all that other stuff comes into this process as well. Okay, so this is one of the tools that you'll see a lot of in the lean world, is this value stream map. And again, it's focused on where's the value being created in the process, and where do we have waste, and that lets us see and highlight what we can eliminate. And as we look at that, we talked about a bit about time. You've got kind of the work time and the wait time. Work time when I'm actually doing something, and sometimes that's called cycle time as well. And then we have the wait time where nothing is happening. It's sitting in inventory, it's sitting in the queue, stuff's waiting to be done. If you add those up, that gives me the overall lead time, which is the time it would take to get a new one pushed through, right? So customers ask for, I need a red one of product A or something like that. I've got from start to finish to get that in. There's time I'll be doing stuff to this red type A thing, and then there's time it'll just be sitting around. That is the lead time of what it will take. So when you ask me, or when the customer orders this, we can tell them, here's how long we think it's going to take before you can have it. It's not going to be today. It'll be at least a week or something like that, based on what we know about the work time and the wait time here. Okay, so that's the overall lead time, and sometimes that is a big problem, is that we're not able to respond quickly to the customer. And if you look at this visually here, the green areas are the cycle time where I'm actually doing some work. The red ones are all the wait time where I'm waiting to get to the next step of the process and probably sitting in some kind of inventory in some way. And even then within the green sections, the cycle time, those may not all be value-added activities, right? I could do the exact same diagram of this for the airplane example that we saw earlier, and we know all those boxes are not actually adding value. There's still work time. I still have to get on the train. I still have to go through the security check. That's part of the cycle time, but it's not actually adding value. So if I can identify those, if I understand what the value is, I get the map out, I measure the times, you can take a huge amount of time out of the process. Again, 70, 80, 90% is not uncommon once you can identify and see it for what it is. And probably not a big surprise, as we've talked about already, most processes are filled with wait time. That is largely what's in there. Think about even something simple like making an email query. And so you think about what you want to say, you write your email. Maybe it takes you 5-10 minutes to write the email. You send it to somebody else, and then we wait. And maybe they respond quickly, but more likely they respond later the same day, maybe tomorrow, maybe a week later. And they spend 5 minutes. They finally read your note. They spend 5 minutes. And they reply to you, and then you read it, right? So the actual work time might have only been 5 or 10 minutes, but it took place over the course of a whole week. Now, of course, we filled our time with other things. We did other activities, but if you look at that process itself, it was almost entirely wait. Nothing other than just waiting for something to happen. Okay, so being able to see waste for what it is, and then have that approach of eliminating, simplifying, synchronizing, combining, and then automating. That's really what creates the breakthrough. Okay, pull. Let's talk a little bit about pull. So this is a slide I mentioned on the in a webinar last week that one of the courses that we do in GELRAD is a 2-day course with a simulation where everybody has a job and there's customers in the corner submitting orders, people working in the middle, and it's a disaster in round 1. So we run the process. Everyone's got their job, but some people are super busy, other people are not, and so on. And we go through and we teach the Lean Six Sigma tools and understand the process, what's happening, do the value stream map, look at the data, and so on, and we achieve the breakthrough. And part of what the concept is the way we teach them. I grabbed this exact slide out of it. It's talking about how we teach the idea of pull. And the way we do that is we make a requirement. The requirement is that you can't start work until your outbox is empty. Right? And your outbox is then the inbox for the person next to you, right? So you can't start work until they've taken the thing that you just finished with. Okay, so you sit and you wait for that to go, and then once that's empty, then you can take something from your inbox, and then you can work on that, and then you put it in your outbox, and you wait for that to clear, and then you pull the next one there, right? And the effect that has is nothing ever can build up in the process, right? No work will happen until somebody at the end of the process takes the lead form to go deliver it to one of the customers. And that creates a hole. And that hole is then now filled in as the person that's last in the process, they do their step and put in the outbox. That creates a hole as soon as they've taken it from the inbox for the next one. And so the hole kind of moves backward through the process. And that, again, has the effect of making sure no work gets done until the customer needs it. So you can't start work until it's empty. There's some kind of signal that I need to do something. And that greatly eliminates the amount of work in process, that inventory that's there. And it also greatly reduces the process lead time. Okay, so let's talk about the inventory. So here we have a process. It's got 3 steps in it. And right now we've got squares in the process. We're making squares, and we've got 30 that are sitting there in inventory for step 1, 50 for step 2, and 20 for step 3. And now I get an order for 20 triangles. You know, so when am I going to have those triangles ready? When will I have the first triangle ready for the customer? When's the first one going to be ready to come out? And you can do a very simple calculation. If we know how quickly things come out at the end of the process, which in this example is 20 units per day, I can add up the number of things that are sitting there as work in process. That's what the WIP is there, work in process. And divide the WIP by the exit rate, and that tells me it's going to take about 5 days. I get 20 units a day, 100 things in inventory. It's going to take 5 days to push them through. And then my triangles will finally have made it through the system, right? If I can reduce the inventory such that there is little or nothing at each one of those steps, then my triangles are come through a whole lot faster than 5 days. You know, and let's say I get it down to only 20 things sitting in inventory in steps 1, 2, and 3. That means that now I've only got a day of stuff to push through the system rather than 5 days worth. And this is where lean thinking can be counterintuitive because we worry. We worry that people in step 2 aren't going to have enough work to do. And it must be right to keep people in step 2 busy. Okay, so then they can just keep producing stuff and getting it ready. Step 3 will take it when they need it. We'll just keep producing because then for the machine, the cost per unit will look low because I've produced that much with the amount of labor resource or machine resource I've used. So the traditional wisdom is get these big machines, keep them well fed, you know, because they're hungry, keep them well fed. But you end up churning through loads of inventory for that. And then, yeah, maybe there is a way to expedite the triangles through, but I've got to have a place to put all these squares while I then get them out of the way to work on the triangles. And there's a huge cost associated with that. Not just the working capital that's there, but I got to put this stuff somewhere, like on a shelf. And I got to pay for that shelf and the building that the shelf is in and the heating and cooling of that building and the electricity, all this kind of stuff, right? So the inventory that's sitting in the system can have a huge effect on the lead time and the cost as well, which is why inventory is one of our forms of waste. So operating with a pull mentality where I only produce something when the customer needs it, I don't keep the machines busy all the time, might actually be both faster and more profitable for you to work. Okay, so it's not just the inventory doesn't just affect lead time; it can also affect our profitability in other ways as well. So I worked with a petrochemicals company and the lubricants business of this company. And one of the products that we worked on was about slobs. And in English, a slob is a lazy person who's generally not all that clean. But slob in this context meant the slow movings and the obsoletes. So a slow moving was a product that we haven't sold single unit of that in the last 6 months. So we have stuff. It's sitting on a shelf in a warehouse or maybe even several warehouses in various places across the geography that we cover. And nobody's bought it in the last 6 months. Or a product that is obsolete, which is that we have a newer product that we are also selling that replaces that one. So let's say it's a lubricant for your car or whatever. We've got newer products that we would rather sell rather than the old ones. So those old ones are made obsolete, but we've still got inventory of that as well. And it is taking up space in the warehouse and so on, right? And so what we looked at in the project is, well, what do we do with all this stuff, right? Ideally, we wouldn't have produced it in the first place because we produced more than what the customer asked for. And this is a form of overproduction, right? This is the overproduction waste, a form of waste called overproduction. I've made more than what you wanted, so it's going to sit in inventory somewhere. So, could we sell it for a discounted price? If so, great. We didn't make the money we thought we were going to make, but we could still make a little bit of money or at least cover most of our costs there. But sometimes you can't do that. Nobody wants to buy it. Could we blend it into a lower grade product, right? Doesn't have quite the same specifications. There's a loss, of course, in doing that because we're selling it cheaper than maybe we should have, but we could still maybe break even there. But sometimes you can't do that given on what are some of the additives that are in the product. Now we're getting into a much less interesting territory where, well, I guess I could burn it to generate some heat, and oil burning that is at least get some value out of that there. And sometimes you can't do that again because of the additives. Could we at least dispose of it by putting it back in the ground? And if you just stop and think about that, we did all the work to go find out where it was, to go drill for it, pull that oil out of the ground, put it through a refining process, put additives in it and blend it to make this lubricant, put it in a package, a plastic bottle usually, take the thing, and then we find a hole in the ground and we dump it right back in, okay? That's the kind of thing that happens. And sometimes, by the way, that can't even work, again, because of the additives that are in it. And now we're gonna pay extra money to have it be disposed of or somehow reprocessed in a particular way. So the inventory can not just be a big delay in our process. As that stuff sits around, it incurs costs sitting there, as well as when we have to get rid of it because nobody wants it. So it might actually be smarter to turn off the machines and take a break. Yeah, it might not be the right thing to do to have every last machine working flat out 24 hours a day, because now we're going to generate loads of inventory and we may not need all those squares that we saw earlier. And instead of, take a break, have a coffee, have a cup of tea, and then take a bit of time to perhaps look at your processes and figure out how to make them even better. Use that time to eliminate some of the waste, measure what's going on somewhere, use it for your continuous improvement activities rather than churning out loads more of this unnecessary inventory. Okay, so that's pull. Now flow, we got a quiz. We got a quiz for you now. This is audience participation time. So in just a moment, Dinesh is going to flash up a survey for you. But let me do the survey. Let me do the setup of the survey first before we pop it up. So let me explain the scenario here, and then we'll get you to vote, and you tell us what you think is the optimal solution here. So we have 6 ships, and these ships are in the harbor. They've arrived at the port. They're full of goods. They need to be unloaded, and we've got 6 cranes available to unload these ships. Now, while the ships are sitting there waiting to be unloaded, or while they're docked and being unloaded, we don't earn any money off of it. Okay, so there's nothing, no value that's there. We just got to get the stuff off there. So now we've got to decide, well, how do we allocate our cranes to our ships here? So I've got a couple choices, and of course anywhere in between. So I could put one crane on each of the ships, okay? And it would take each of those cranes 6 days for them to unload the ship that has been assigned to them. And in 6 days, all the ships are unloaded, okay? The other extreme is, of course, I could allocate all 6 of my cranes to a single ship, and it would take only 1 day to unload that one. But of course, the other 5 of them are sitting there waiting and nothing is happening. Third one, and so on. And then in 6 days, all the ships have been unloaded. So in either scenario, it's going to take 6 days to unload the ships. The question is, how do you allocate your cranes to the docking ships to maximize your revenue? Okay, so now, Dinesh, can you please pull up the survey? We'd like you to vote now. We'll give you 10, 15 seconds to think about it. If you were in charge, what would you do? Would it be 1 each per ship? Would it be all 6 of them in one, or anywhere in between? Okay, if you could pop up the survey, please, that would be great.
Yeah. Okay, friends, there will be now a survey pop-up on your screen. It has a multiple choice questions. You have to select 1 out of the 6 choices given to you.
Okay. Give you just a few more seconds. Again, our extreme options are putting 1 crane on each ship, and they all get unloaded at the same time. Any other option means that there'll be some ships sitting there going, "Hey, what about me? I got stuff. You know, you're not unloading me there." And the most extreme version of that is that we get all 6 of our cranes unloading a ship at a time, and I will not submit for myself. Okay. Do we have Dinesh? Do we have a good number of responses?
Yes, sir. We have a 30 out of 54.
Okay, that's 30 enough. Let's go ahead.
It's still going on.
Oh, yes, they're still coming. Okay, let's take 5. Let's just take a few more seconds, and then we'll see what the bulk of the group chose as their. Okay, yeah, let's go ahead and close the poll, and let's have a look. And please put up the results.
I'm sharing the result.
Looks like we have 39% of the group have chosen that all 6 cranes unload 1 ship at a time. That was our most selected option. We have 24% choosing spreading out the cranes, 1 on each ship. And then we have some variance in the middle of 2, 3, and 4. Nobody likes 5 though, poor 5. Okay, well, so we can run the numbers and we can actually have a look. What's the impact of choosing either one of these extreme options? And of course, the middle options will fall somewhere in the middle. So I'm going to close actually, I'm going to leave this poll down here so I can just have it handy. Okay, so if you have a look, the table we've got in the upper left here, this is what it looks like if we have 1 crane per ship. What is actually happening each day of those 6 days while each of those 6 ships are being unloaded, right? So it's basically a batch size of 6 that I'm doing with my 6 cranes there. And they take 36 ship days to unload. Each crane works for 6 days on each ship. There's 36 work days that are being expended there to do that. So no money's being made during that time. But it feels good. Like if I'm a manager, all my ships are being worked on. Everybody's getting unloaded. All the captains are happy because they're getting some attention in that. I feel like things are under control because nothing's being ignored in that way. The only trouble is it's not all that efficient. So if you look at the table in the lower right now, this is the other extreme of allocating 6 cranes per ship. And on day 1, we unload in its entirety the first ship. And then it can go off to the sea and start making money, go get more cargo and start making money here. And I'm not going to pay port fees and things like that. But as a leader, it kind of looks annoying in that I've got another 5 ships that are sitting there not being worked on at all. And of course, those captains might be complaining and having things to say about that. It feels like I'm not doing the right thing there, but actually it's a far more efficient approach. Instead of 36 days of work being done, it's actually only 21 ship days there. And I get a chance to get them out to back out to the sea. So it's still, my cranes are still working for 6 days, but it's far more efficient in terms of maximizing the revenue and getting the ships out to continue. And this is called single piece flow. So rather than working on a giant batch and doing them all in one big chunk and then throwing that giant batch across to the next process step, I work on them one at a time, and I finish them. And by the way, choosing 4 cranes dedicated to a ship at a time still does better than 6 cranes that are spread out across all the ships. Okay, now that's an exercise for the reader to go ahead and prove to me why 4 cranes can still do better in terms of the number of days waiting or unloading there. Okay, so 4. So I can even take 2 of my cranes, put them on other activities, and have the 4 cranes remaining have still fewer ship days waiting. The elapsed time goes longer, but still the actual ship days are being stuck in port are still better than spreading my 6, better than the 36. Okay, so this is the idea of flow. Eliminate those delays between steps and get rid of the batch and queue mentality and focus on single piece flow. But of course, we have a couple hundred years of history that has encouraged us with this batch and queue kind of thinking. Do a big batch because Adam Smith told us it was a good idea. And this is the back of a 20-pound note of the Bank of England. At the moment, this is who's on it. It's Adam Smith. You can see here's why we put him on our money: the division of labor in pin manufacturing and the great increase in the quantity of work that results. And he was right. 200 years ago, this was a pretty good idea to do this. If you focus me on a task, I learned how to do it really well and really quickly, and the muscle memory and everything that goes with that, and I can just start churning these things out. And the context in which he was talking about this was manufacturing pins. Versus, if I have to do all the tasks that are necessary, I won't quite be as fast. And that worked for a long time. The only trouble is it creates new problems. It creates new problems, especially in these modern times when we have machines to do this. It creates these problems like inventory, right? And we start producing all this extra stuff that is there. And also, there's even a boredom factor that becomes important as well, right? So, when you're doing the same thing over and over, it's very easy to stop paying attention, right? System 1 gets really good at it, and then we sort of miss it when things start to go wrong. In fact, one of the products we coached many years ago was looking at the time it took to do an activity that was running a model. This was actually also for the oil company. And this model would run overnight, and sometimes there would be mistakes that would happen. And we were looking, well, what are the reasons why the mistakes happen? And the people running the project thought that the people who did it regularly would make the fewest mistakes, and the people who only did it occasionally when they were doing cover for holidays and other sickness and things like that, we thought those people would make more mistakes. And in reality, it was actually the opposite. So the people who only did it occasionally did it better simply because when it came time to do it, they pulled the instructions out and they followed the instructions, versus the people that are just doing it mindlessly all the time. Okay, so we kind of have this long history of thinking, yeah, big machines churning out big batches of things, that's how you're efficient. When actually it creates a whole host of new forms of waste that could be financially crippling for the company. So rather than having a big long assembly line, maybe I make myself a small little cell where I can do all the activities that I need to do all in one place. And I, as a worker, I can do them start to finish. And of course, I learn all of them and I get good at all of them. And then I don't have all these big chunks of inventory sitting there in the middle. Okay, so that's just a brief overview of the ideas of flow. Well done on the quiz, you guys. You got the right answer in terms of we had 40% of you doing that. It is the most efficient from a workday time to focus and finish. That's really what single piece flow is about, and it eliminates a lot of the issues of waste. Okay, so just a few minutes briefly on perfection so we can get onto taking some questions. Again, this is where we have a nice connection with Six Sigma. It's always cheaper to do things right the first time. Right? There's a great book called Quality is Free, mid-1980s, maybe 1984. Philip Crosby is that book. And the reason he says quality is free is this reason. It's always cheaper to do things right the first time. This was in the total quality management days of zero defects, right? So we tend to think of quality as being high quality means high cost. But actually it's the other way around. You know, if you do things well and you do them right, it's going to cost you less to produce. Maybe you can charge more for your customer. Maybe that's why we have that association. But from a production perspective, if you have good processes with a minimum of waste there, you're going to do things right the first time. It's going to be cheaper than all the rework that you have to do to fix it when things go wrong. And this ties nicely into the concepts of efficiency and effectiveness. This is often how we measure how well things are going. And efficiency is about the waste, the rework, how much sort of cost and time did it take to do that, whereas effectiveness is, did we get the right result for the customer? So, you know, so delivering what the customer requires and doing that with a minimum of waste and the rework. And these two things go very nicely together. They are two sides of the same coin, in that it's often very difficult to be effective if you are also inefficient, right? So if we can be efficient, the effectiveness will often come with that. You know, doing things right the first time means you're going to get a great result. So again, car manufacturing was mentioned. So imagine you're producing cars, and you know, you're the guy, you're the person whose job it is to put the car door on, and you know, and one of the doors doesn't close quite perfectly, right? It should go in easily, make that nice thunk noise that it makes when it closes. But you notice that maybe it isn't perfect there. You could just sort of throw your hip into it and make it close. You know, it's not that far off, and it would be fine, and you could carry on and do your job. But that's stuff that maybe isn't quite perfect. The customer certainly won't be happy with that, and that variation, the research shows it's much more likely that's the stuff that's going to go wrong later, and then we're going to have to apologize to the customer, do a warranty repair or something like that, right? So being efficient in how we work and minimizing those wastes and those defects, you know, as one of our forms of waste there, also leads to effectiveness. So these things go very, very nicely hand in hand. And from the Six Sigma world, that idea of reducing variation really helps me with that. Just one of the concepts in the lean world around perfection is this idea of mistake proofing. You've probably heard of this before. The Japanese for this is Poka-Yoke. I don't speak Japanese. If you do, I'm sorry that I just butchered your language. But it really means to avoid errors there and make it either difficult or ideally impossible for mistakes to happen, you know, through the wrong action of a human, right? It's really the idea, the ethos or the idea of mistake proofing is to avoid those inadvertent errors, right? So if someone really wants to break something, they'll probably find a way to do it. What we don't want, and what mistake proofing about, is eliminating those accidental mistakes that are here. So make it easier to discover when they occur, or even better, that they're about to occur. And even if you do the wrong thing, we still get the right outcome coming out of it. So the system or the process is robust to be able to do that. There's examples that are here in the table below. I won't read through them for you, but in some cases they're able to, these things help you detect that something has happened, or we can take action to prevent it from going wrong, right? So I'll pick on one of them. You know, we've all experienced the computer input ports being different sizes and shapes. We all have had the experience with a USB, like the traditional USB sort of thing, where it doesn't matter the way you hold it, regardless. The first time you try to plug it into the computer, it will always be wrong. And then you turn it over, and it doesn't fit that way either. And then you turn it back the first way that you did it, and then it finally goes in. You know, invariably, it seems to happen like that. And they've eliminated that now with USB-C. And so you can plug it in this way, or you can plug it in that way. And yeah, plug it in any way you like. The only way you're going to make it fit in still works. It still is actually okay to do that. So this is the idea of the principles of mistake proofing. Okay, so I want to get on to questions. So just brief wrap. So again, these are the 5 principles of lean. There are many tools that sit behind all of these things. We'll look at a few of them when we get together in a week. So first of all, identify what is the value, and that is really from the customer's perspective. What is it that they are paying us to do for this process? And whether that customer is internal or external, what's the purpose of this process? What are the activities that we go through in order to produce that value? Where's the time spent? What are the wasted steps that are going on? Let's make sure we work according to the principles of pull, so we don't start generating loads of inventory. We make things when the customer needs them. We eliminate the waste between steps with flow, those delays, and then we make sure we do things right the first time. Those are the ideas. Okay, I am ready for some questions.
Okay, thank you very much, Mr. Dev, for this wonderful session on lean management, where you have covered the concepts like value-added activity, value-enabling activities, non-value-added activities. Then about the team wood, that's identifying a 7 type of waste. Then 5 action which we can take like eliminate, simplify, synchronize, combine, and then automate. Importance of inventory, the concept of slopes, that's the slow moving and obsolete items, and the flow. There are some questions which has come up in the discussion. However, friends, let me mention here that some of the participants have requested that can all this concept be covered in a more detailed workshop. So Navrachana University, along with the GELRAD, we are planning to conduct a yellow belt and green belt certification program where we are going to cover all these concepts in a workshop mode somewhere in the end of the August or start of the September. We will keep you informed about this. However, for this session, let me go ahead and read out some of the questions.
Okay, great.
This first question is from Ms. Mili Lapsiwala. How can we use our past experience in IT field, especially for coding?
How can we use our past experience in the IT field, especially for coding? So how can we apply lean principles in kind of an IT world? Right, well, I didn't talk about it today just because of time really, but I'm sure you'll have heard of Agile. Agile came from lean. So the people who developed Agile are lean practitioners. That's where the methodology and the approach comes from. It's kind of a specific application of lean principles for the software development kind of environment. So if you've not had some training and experience in Agile already, I would strongly recommend that you do that, at least do some research there and have some reading. But again, the same principles that we covered absolutely apply. It's just we're looking at electronic processes rather than manufacturing processes. So think about value. So what is it that this application we're developing is meant to do? What are we trying to produce for the customers? Let's make sure we stay focused on that, not what we think they would want. There is a role for that, trying things out and innovation that's there, but most of the time we have a specific use case in mind of what it is we're developing for, specifically for what the customer needs, rather than some things we think might be interesting or useful. There. What's that customer experience going to be like? What does the process look like for them? How can we make it as easy and as fast for them to do the things that they need to do as well? I do a different course about just customer experience. Putting yourself in the customer's shoes, and we talk about the customer's jobs to be done. What is it that the customer is trying to achieve with whatever this application is, the software that we're doing? And often is not what we think it is. So how can we go observe them and watch them, what it is that they are doing with our software, and what insights can we get from that? Again, we haven't talked about design thinking either, but that sort of observing the customer fits in that methodology as well. Okay, so absolutely, you can use the same principles and apply them to the software development lifecycle. How we look at the voice of customer. I mean, even the stuff from last week in Six Sigma applies very nicely in the software. When I worked at GE, I started at nuclear engineering, and then I became an IT manager, and I did the rest of my GE career in an IT world. So when my first green belt project was on reducing reports, the amount of processing time we're using to generate the daily, monthly, and quarterly sales reports there. So it really was a lean project that I did.
Thank you very much. The next question is from Mr. Haresh Ralgavkar. He says, there's a professionally managed company who is ISO certified. For such type of company, how much time it will take to implement Lean Six Sigma?
Right. Okay, so I'll give you a very British answer to that one, which is, how long is a piece of string? That's what British people would say. And what I mean by that is, it entirely depends on a great many factors, right? So being ISO certified is very good, right? It means that you've got a level of documentation and some structure to what you have in terms of your process. But the ISO standard doesn't guarantee that that your processes are any good. It just means that I've got to, that's maybe a broad generalization. I apologize for that. But that's not the purpose of ISO certification. It's to say I have the most optimal processes. It's to say I do what I say and I say what I do, and it's well captured there, right? And the customers understand what's happening, or the standards bodies or whatever. If you have a great engaged leadership who believes in the principles of Lean Six Sigma, who is going to make sure the organization has time, that we apply the right focus, that we choose the right projects, it's the kind of thing that you could make significant even in the first year or two around changing how the organization works. I mean, this kind of stuff, to change a whole organization, we're talking multiple years of dedicated effort, because it's not just about applying some tools, you're changing how the organization thinks. If you think about when GE did it 25 years ago, it was 1995, and Jack said, we want to be a Six Sigma company by the year 2000. Right? He didn't say we want to be Six Sigma in the next 6 months. Like it's gonna take some time to do it. And by the way, they're still going, on it. But it's changing the mindset and changing the way you think about it. So in the end, if I had to pick one thing that ultimately is the main driver of that, it is the one I mentioned already, which is the leadership commitment to doing this. And that is nothing unique to Lean Six Sigma. For any sort of initiative that the company wants, if the leaders commit, the time will be spent, the training will happen, the coaching will happen, the products will deliver, and the transformation can happen. If the leaders don't, it won't.
Thank you very much, sir. This question from Mr. Harish, once again, from NMMS. He says, for an organization, do you suggest to go for Six Sigma first and then Lean Six Sigma, or an organization can go directly for the Lean Six Sigma?
Yeah, okay, yeah, so I commented slightly on this earlier in that I do not see them as separate things, and my experience is that they are not separate things. They are maybe, if you think back to the slide I have that has the triangle, where we talk about variation. Six Sigma came from a world of variation. Lean came from a world of waste. We have something called Design for Six Sigma, which is about when I don't have a process or I need to completely redesign what I have, there's a methodology I can take to do that. Because sometimes in the end, even with you take all the waste out of the process, it may still not be good enough, right? Like if I've got to, what's an example? If I've got to get to work, and you think about the best your commute is ever going to be, there's going to be a finite number to that, based on the traffic and whether it's a bus that you're on or your car or bike or whatever, there's some limit there. And if you ever need to be better than that limit, even on like think about, you made every light, there was no traffic, it's still going to take some time to get to work. If you still need the process to be better than that, I now need new technology. I need my helicopter or hovercraft, personal hovercraft or whatever, that's going to take me above everything and take there. There's a whole methodology around doing that. So when we work with companies, we don't go in and say, we're going to do a Lean implementation, we're going to do a Six Sigma implementation. We often use the more general words of continuous improvement. And with some of our customers, we even take it and customize the methodology to fit with the culture and the environment of the group that we're working with. So it's not like it's not a question of one or the other. It's pretty hard to do only one of them and ignore the tools that come from the rest, because you're going to encounter problems that need the tools of Six Sigma, the tools of Lean, and occasionally some of the tools of Design for Six Sigma.
Thank you very much, sir. The question from Mr. Anush Tiwari: how can Lean help us in phasing in new products, for example, BS6 vehicle parts, which does not have a defined consumption history?
So I missed the last part of that. So how do we use Lean Six Sigma for phasing in new products, and then the connection broke up?
Which doesn't have a consumption history. We don't have historical data about product.
About consumption data, about how much the customer demands or how much we need to produce. I'm not entirely sure I understand the question.
How much the consumption pattern what is the consumption pattern of the product? Because we don't have a past history about the new product.
Gotcha. Okay, so it's a new product. We don't know, right? Okay, yeah. So, we may not know for this specific product, but there probably is some history we can look at and get some understanding of what has happened for us in the past, as well as if you can apply these principles. So if I'm creating something new, and this is kind of the design for Lean Six Sigma that we spoke about just a moment ago, if I can design it with that minimum of waste and rework in there, with reducing the variation from the beginning, I have a lot more flexibility. So I may not know what the demand is, but I want to make sure that I'm going to be able to meet it, whether they ask for 500 or they ask for 5,000, and then I can tune my process accordingly. So these same principles and techniques you can apply as you create the new process, because it's so easy to create a process that has lots of non-value-added stuff in it. Because it seems like a good idea, it'd be helpful to have this, helpful to have that. But if you don't really think about it and measure how long that will take or how much resource it will take, all of a sudden it's easy to make something that grows and is big. So I would apply these principles from a design perspective to try to make your process as ready as it possibly can be for the growth, even in your wildest dreams. And then you probably have different considerations around physical space for manufacturing if you want to increase. But for whatever process we want to do, let's try and make that as lean as possible, so you've got the most flexibility. I don't know if that answers your question or not. So please ask a follow-up if it does not.
Yeah. There's a question from Mr. Malhar. How to define minimum lot size?
Right. So probably not something we can drill into in this particular webinar. I don't know if we'll be able to include that in the one next week. The example I gave earlier about the slobs, the company that I was working with, they do a lot of work around what are those economic batch quantities to do. And so there's a whole field of study and science around doing that. What to include around how your machine works, production hours, like for doing oil, how big are the vats that you are doing the blending in, how long does the blending take, and so on. So it's very particular to a process, what factors matter for that. But as a general principle, the smaller you can make those batch sizes, the better. So if you can get it down to a single piece, because then you've minimized the amount of inventory that's going to sit there in the process. And so when the customer says, okay, now I want a red triangle, you're able to produce that very quickly because you don't have large batch sizes in the middle. Now, we know we have to do things like build safety stocks. We know things go wrong with machines and so on, right? So it's rare that you'll see a place that has zero inventory. So there is some kind of level there, but it really comes down to applying that principle of trying to make your batch sizes as small as you can possibly make them to, again, give you the lowest amount of waste and keep the most amount of flexibility. And again, there's online studies. I'm sure you can look it up for your specific situation, or we can perhaps do some coaching if you're interested.
Thank you. The next question is from Mr. Nirav Pandya. From your experience, can you give an example for the non-value-added activity in pharma cleaning?
I do not have pharma experience, but I do know someone who does. So if it's okay, I would actually call on Ram if he is connected. Ram, if maybe we could unmute Ram. And Ram could give us an example, and maybe ask the question again, just so it gives Ram a chance to listen. Ram, is that okay? Maybe raise your hand if that's okay, Ram. He may not know how to raise his hand.
Just a minute, I'll just unmute Mr. Ram.
Okay, perfect. That would be great.
Mr. Ram?
Yes, I'm here. Thank you. That question. Can you please repeat the question?
So the question is, can you give an example of non-value-added activity from pharmaceutical industry, specifically cleaning process?
Cleaning? You said?
Cleaning process, pharma cleaning.
I'll give the example from the pharma in general. Pharma consists of three things: in discovery and clinical trials, manufacturing, and marketing. There's four phases in general. Right now for COVID, we are going to go to phase 3 trials. And the waste in all those things are tremendous. Right now, the typical cost of doing a COVID trial phase 3, it may cost anywhere from $100 million to $300 million. But if you draw the process map, you will see the amount of weight you need to do. Do that, the amount of Tim Wood is tremendous. In fact, it could be done much, much faster. That is just on the phase trial, in the clinical trials. Even in the R&D side and the discovery side, there is a lot of problem. We could reduce that one also. And of course, in manufacturing, every step, there is a Tim Wood, there's a transportation, unnecessary motion, lots of inventory where this important medicine is getting a slob, it's getting obsolete, and we need to dispose this poison carefully. So you can see transportation, inventory, motion, weight, overproduction, overprocessing, and ultimately defective products. So that lives there too. And this one applies to every phase, cleaning them for the good manufacturing practices, cleaning the labs, cleaning the manufacturing. You see how many times people need to take on their suits, take off their suits. So at every step of the way, there is waste that could be eliminated using lean in the cleaning process, the discovery process, and also in the marketing process. How do you access the market?
Thank you, Mr. Ram. There's a question from Mr. Dilip
Ram,
Mathur.
just for the benefit of the audience, let me introduce Ram. Ram is also a co-founder of GELRAD, and he's based in the United States. He's done his master's from the Massachusetts Institute of Technology and his bachelor's in technology from the Indian Institute of Technology in Madras. Thank you, Ram.
Thank you.
Yeah. There's a question from Mr. Dilip Mathur about what are the various human issues in implementation. For example, motivating people or overcoming the resistance posed by the people.
Yeah. So there's a few things that are common that we've seen with a lot of the customers we work with. And one of them is just time, right? Having the time to dedicate to this. And so when you're first getting started and choosing the first wave of project, right? So we had that question earlier, when you want to get started, how long does it take? A lot of that also depends on how you get started. So when you first get started, it's a great idea to pick the kind of projects that save you time. And you may have heard this language before, time thieves. What are the things that are stealing your time? Because if you can work on those, that then frees up the people's time to then do additional continuous improvement. So the human side of things, having the time to work on it is the number one thing that I see that causes the delay in projects. It's also the sponsors, as I mentioned before, the leadership, how well the leaderships are committed to that. So I did a sponsor training for a customer this morning, and that was one of the comments is if you got, it's not important what the question was, but my comment was, it's down to you guys. Ultimately projects fail because you guys don't get involved. And one of the things that the sponsors are there to do is to help overcome that resistance. So when we do have issues with the human side of change, what are we going to do to resolve that? And the sponsors can play a big role in that. And so we didn't have, again, the time to talk about it in this webinar, but there is a whole methodology around change acceleration, and it's a change acceleration process. It's a methodology developed by GE. And there's a number of elements and tools within that are applying the same kind of rigor that we do in our Lean and Six Sigma world to the human side of change. So for example, if I need to build a case that we want to change and do things differently, and then we need that for this product or something, I might use a tool that allows me to systematically go through and look at what are the threats that we face if we don't change. What are the opportunities that we face if we could do something different? And then what are the threats we face if we do make the change? Because things could go wrong and I could have problems there, right? So then when I go to talk to someone, if I brainstorm all these different parts, when I go to engage with someone, I can have a dialogue, and I'm coming with a much more balanced picture, not just coming saying, hey, it's going to be great to do this product and make this change. It'll be wonderful. I can also come in and say, I know things could go wrong as well, right? So we're going to work with you to mitigate the possibility of that damage. So actually there's other methodologies as well that we blend in with the work that we do all around influencing the humans and bringing them along on the change. So those are kind of the two biggest ones. Do I have time for this? And do I believe that it's worth it? Like, or do I have the time to help you on your project? And that's where some of these additional tools and thought processes can help accelerate that change.
Any more questions, Dinesh?
Okay. The next question is from Ms. Richa Shah, where she says that Lean Six Sigma focuses on reducing waste. So can we say that Lean Six Sigma and sustainable business go hand in hand?
I'm not sure if when you say sustainable business, if that refers to a specific thing or approach or methodology, but in general, to do Lean and Six Sigma well, to do the Lean Six Sigma approach well, the last bit of it is always about the sustainability. So in the Lean Six Sigma methodology, the control phase is about assuring that it is sustainable. So all the work that we do, when you come up with your great ideas for how we want to change and make things better, you've got to do things that are, you got to make changes that are actually going to work in the long term. And I can't remember if I did this example a week ago, because I know I've used it on one of the courses I've done in the last couple of weeks. But if you think about weight loss, if you want to lose weight, I've got the perfect diet for you, guaranteed to work. Do not eat today or drink anything. And I guarantee you, you will weigh less tomorrow, right? But that is not a long-term sustainable solution there. It works, but it's not a good one, right? And you can do it. And what we sometimes see is the ideas that come up, that people come up with are, for improving the processes, are those, that are business equivalent of don't eat today, right? It's a system one thing. It comes to you very quickly and easily. It definitely works. The only trouble is there's no way you're going to carry on being able to do that. So that's part of what we look at when we're working through solving the problems using the tools. What does that long-term sustainability plan look like? If we can't totally mistake-proof it and make it so you can't, so things don't ever go wrong, what are you going to keep in? Who's going to do that work, to do the ongoing monitoring? And what actions do we take when we see a change or we see things that start to go wrong? Yeah. So really, these tools and approaches will help you make changes that will keep things sustainable in the long term. I don't know if that answered your question.
Yeah. There's one question from Mr. Saurabh. He's asking, what are the various computer softwares and tools that are commonly used by the companies in Lean Six Sigma project?
Yeah, so I can speak from personal experience and the companies that we work with. I mean, a lot of it is Excel. There's a lot you can do with Microsoft Excel because most projects don't need super sophisticated data analysis, and Excel just makes things better and better as the years go on. Get your data in the form that you can put it in a pivot table, and there's an awful lot you can do with it. Even some of the statistical testing, sampling, there's loads of that. So that's probably, if I had to say, that is the #1 software tool that I use in my projects. In terms of packages beyond that, certainly for statistical analysis, I had GE 20 whatever years ago, and so that's my favorite one. That's the one that I certainly use the most. I've worked at other companies where they use JMP, SPSS. I know you can do stuff with R and so on, right? So there are some options out there. I guess I would say, I don't know, do I see less Minitab these days? It's kind of tough to say. A lot of the companies that we're working with, we are working at the more lower level, like less sophisticated kind of projects. We're not doing any of the ones that I need to build a multiple regression model. I shouldn't say any, but we're doing relatively few of those. It's more about, let's get the process map, let's identify where the waste is, perhaps more of the lean tools. But when we need it, something like Minitab is absolutely brilliant for doing the sophisticated model that can allow you to let's throw all 20 of the variables in and help us to figure out what does. So things like, again, Minitab, Jump, SPSS, and so on. There's actually a lot of collaborative tools out there as well, for doing things like process mapping. So it used to just be Visio and everyone used Visio. But there are loads of ones out there that where you can have collaborative, in the cloud working on things. So one of them that I quite like is Lucidchart. That's very good for doing process mapping through a web browser. And then anybody in multiple locations, we can all work on the same map at the same time. It's not the only one of those. It's just one of the ones I've used quite a lot, quite frequently there. And then loads of tools around for collaborative work. where again, teams in disparate locations or stuck at home due to COVID and so on can work collaboratively. Obviously, there's Microsoft Teams. We use that with one of our customers. Another one we use Quip, which is again a collaborative environment. In fact, you can do Lucidchart in Quip through that one as well. So there are many things out there, but if I had to pick my number one, it's Microsoft Excel.
Okay, sir, we have one last question from Mr. Harish, NMIMS. Apart from training on tools and behavioral changes, are there any other specific costs involved in going for Lean Six Sigma?
So yeah, so there's obviously a cost to the training and the education that comes with that. There's coaching as well, right? So in general, we advise coaching for every project. And there's a lot of reasons for that. But if you just stop and think about it intellectually or philosophically, like think about sports thing, right? So cricketers is what I should be choosing given the audience here. I'm afraid I'm not quite up on naming famous cricketers. But if we think about famous cricketers, even they have coaches, right? So the people who are the best at this sport in the world, even they have coaches. And so I know some football players here. There's somebody who's a dad at my kid's school. David Stockdale is his name. One of the other dads. He's, of all the people I've met in my life, he's the best football player I've ever known. And he's got a coach. In fact, it's not even just a coach just for the team. There's a specific coach just for the goalkeepers, right? That's the position he plays, right? So that is definitely another piece of it, is that make sure you've got some coaching support and advice that is there. And then also, if you want to go for a level of certification, usually there is some kind of review involved with your project, and then taking a test depending on the level that you're actually going for. And there's usually a cost associated with that as well. I don't know, Pravir, if there's anything you want to add in terms of the program as you guys have designed it for the university.
Yeah, the important thing is that these webinars, it's like picking up a book on how to swim and then hoping that we can be expert swimmers. Really, you know, that you learn by actually doing things. So being able to find out an improvement project in real workplace and applying all these concepts, everything that you have learned, that's extremely important. So becoming a practitioner requires that you pick up a problem, work on this, apply these things. And as soon as you try to do that, you would realize that, oh my God, it was very clear in the classroom or on the webinar, but now I don't know how to proceed. And this is why coaching becomes extremely important. The coach will not be a professor who says, let me tell you what's wrong, but coach would say, well, try this. Did you try that? And coach will help you move your projects forward. And then you learn a lot by actually doing things. So we're very glad that over a period of 2 decades that we have existed as a company, GELRAD has turned thousands and thousands of people into actual Lean Six Sigma practitioners. And we will welcome, you know, any thoughts or feedback or questions that you might have later on, that, hey, I'm trying to do this, or I have problems, or how do I find problems in my company? If you want to have that discussion through the Center for Professional Education in Navrachana University, we definitely welcome that kind of discussion. We'll see what we can do to help you out.
Yeah.
Right.
Yeah. Thank you, Mr. Pravir.
Thank you.
In fact, we also received.
If I can make a comment.
Sure, sir.
Thank you, Pravir bhai, for your comments. You know, I'd just like to add on to what Dave and Pravir mentioned. If you remember, Harish, if there is a very classic case study which we teach in management schools in our class in information systems, and we talk about the total cost of ownership of information systems. It's a classic question that has existed right from the past till today. It still exists and will exist. There is a huge tangible component, but there's also a huge intangible component on both the cost as well as the benefits. And one of the aspects of cost, which is very difficult to measure, is the aspect of change and managing change. And this is true when you apply any new management concept also, whether it's Lean Six Sigma or any other technology or tool. And this is where guidance or choosing the right partner whom you can stay with, who will guide you through and through in this change management process, that is very critical. And that is, so you got to buffer in all that whenever you're talking of the total cost of ownership. It's not just the cost of the hardware and the software alone. It's much more than that. So that's what I thought I would just add on.
Yeah. And friends, as I mentioned earlier, there are some of the participants who are requested, can we get some practical exposure onto these concepts? So in the month of August, end of August or start of September, we are coming out with a workshop, which will be basically going to be hands-on, as Mr. Pravir has mentioned, for green belt, yellow belt and green belt certification, which will cover this Lean Six Sigma concepts. And we will keep you updated about this program, which are going to be offered through Center for Professional Education from Navrachana University in collaboration with GELRAD.
Elaine, would you like to offer your comments?
I'm unmuted. Thank you. First of all, I'd like to thank everyone. I thought it was another excellent session today and appreciate everyone's questions and participation. I look forward, as I'm sitting here listening to the session and the questions, I think there are so many other topics in these short webinars that we can deliver and have people after these sessions go back to their workplaces, go back to their activities and think a little bit differently. So it's changing mindsets. And we have lots of other things, especially along the change management practice that we can share with the team. So thank you very much. And I look forward to our session next week.
Okay. Thank you so much. Thank you, Dave, for a wonderful session today. Thank you, Pravir, Ram, and Elaine for joining us all the way from the US and from the UK. I'd like to thank the whole audience here who participated very actively. And thanks to Dinesh, who coordinated this whole session today. Thank you so much. Next week, we will have our part 3 of this webinar series, which is Six Sigma Tools and Concepts. Same day, Tuesday, same time. I'm Dr. Nilay Yagnik, Provost of Navrachana University. Thanks for joining us and have a nice day. Bye.